Hey guys, so today I'm going to go over the process unit of a filter. So we're just going to jump right in and go ahead and go over the operation of a simple filter. So what you do is you start off with a solid liquid mixture, which is this up here right above the filter, and you would kind of just dump it into the filter, and at the bottom it kind of just collects the filter cake, which is the solid, and the liquid part called the filtrate drains out right there. So that is just a simple filter for you, and that is how all that works. So some or all of the solids are removed by the filter, and the solids are the filter cake. That's what I just went over. So this is a more detailed drawing for you, kind of just explaining how all the solids are caught in this little hole. The big particles are the solids, and the small particles are the liquids, or the parts that get through, which is the filtrate. Okay, so one of the most common uses of filters in everyday life is coffee making. In coffee making, you take a hot water and a coffee ground solid liquid mixture, and you insert it into the filter or the coffee maker, and the coffee grounds collect right here as the filter cake, and the hot water filtrates through the coffee grounds and takes the pure coffee and transfers it into the mug or whatever you're collecting the coffee in. So the liquid goes through while the solid is left behind. So the liquid part of the coffee ground would go through while the solid part of the coffee ground would be left behind. So two more examples of filters are strainers and filter cloth, and they kind of work in similar ways. So filter cloth or paper consists of different types of fibers layered to create pores that allow liquid to flow through while collecting solid particles. This is similar to what strainers do, which strainers are what is shown as these two images right here. So they also collect solid particles, but they do so with these tiny openings in the metal, as you can see. I can't circle one of them, but you can see the tiny openings right there. So the filter cloth is similar in that way, in that the liquid will flow through them, but the solid will be collected. And you can see the examples right there. So the synthetic, nylon or polyester, natural, cotton or wool. So the filter cloth is used for cake filtration. A cartridge filter is a filter created out of rolls of filter media wound so that several layers of filter media cover each other. The first example of a cartridge filter is a pleated cartridge filter. This type of cartridge filter acts simply as a surface filter, in which the filter media simply block the solid particles from flowing through it. So in the top image, this is an example of a pleated surface filter. So the solid would kind of just collect at the surface right here and not actually make it through the filter. And whereas in the bottom image, this would be an example of a depth filter. So when it has wound layers of filter media, the filter is a depth filter, in which the many layers collect the solid particles as the mixture flows through it. So the solid would collect at the many different layers of the actual filter, and not just at the surface, as in the pleated filter. So once again, the bottom filter is the depth filter, created out of wound layers, and the top filter is the pleated filter, created out of the one layer. Bag filters consist of felt, a porous membrane, or layers of mesh made out of natural or synthetic fibers. They are often placed inside housing and a slurry runs through them. They're used to collect dust and other contaminants in metal factories. So they are kind of simple filters. They're easily taken out of machines. Some can be used in big machines like this on the industrial level as well, and you can also find them around the home in simple machines. Filter presses consist of several filter plates in series. These plates are metal frames containing large sheets of filter cloth, usually polypropylene. These plates are squeezed together and the slurry is filtered through the press. So how this works is the slurry deposits solids on the filter cloth as the filtrate leaves the press via discharge ports. Pressure filters. So when the slurry is pumped into a pressure filter, extremely high pressure drives the slurry into the filter medium. The filtrate is forced through while solids accumulate onto the medium. It's usually belt driven or a belt itself, much like a vacuum filter, to achieve continuous operation. Next up are vacuum filters. So they use the application of suction on the filtrate side of the filter medium during filtration. Horizontal belt vacuum filters contain a conveyor belt to move the filter media from a roll through the machine. So as you can see in the top picture, the slurry feed goes in on this conveyor belt and the filter cake will go off. But the cake wash liquor actually pushes the filtrate down. So the filtrate cake will go off while the filtrate is coming down, as we went over the principles of liquid and solid separation earlier in a simple filter. So it's going to the vacuum receiver. The vacuum pump is being the thing that pulls the filtrate this way, and the filtrate would actually be collected down here at the bottom. The rotary drum vacuum filter works a little bit different, but it uses the same principles. So rotary drum vacuum filters consist of a rotating drum lined with filter medium that has approximately 1/3 of its outer wall submerged in the slurry. So as you can see right here, the slurry level touches about 1/3 of that rotary drum wall. The filtrate is pulled through the wall of the drum by a vacuum towards the center of the drum. So you can see that in the picture as well, the vacuum pump being all the way over here in the center of the drum right there. The drum rotates such that the cake is dumped into the discharge outlet. That section of the drum wall is then washed before performing the filtration again. So those are vacuum filters in a nutshell for y'all. The horizontal vacuum filter and the rotary drum vacuum filter. Fabric filters are primarily used in dust collection. So how they work is that dust is removed from a gas stream by passing it through the fabric. So they are fairly simple, probably one of the simplest filters besides a coffee filter. So the fabric pores are very large. Efficiency is low until the dust precoat builds up. So the more dust you have in this filter, the more efficient it actually becomes, because the dust actually becomes thicker so it can block more and more dust. So once the precoat is established, penetration is very low, which is good if you're trying to block off the dust. If you want to clean a fabric filter in industrial use, they generally must be taken offline for cleaning, as well as if you're cleaning out a washing machine or a dryer, to say the least, you have to take it out. Depth bed filters. So in a depth bed filter, the slurry is filtered through a thick bed of filter medium, usually consisting of many grain-sized particles. As the slurry passes through the bed, the solid particles being filtered out are caught by the grains due to gravity settling, diffusion, or molecular or electrostatic forces, and are separated from the filtrate particles. So as you can see, the slurry is going through and the solids are being fused to some of the bed particles. So some of the solids will get fused to these particles, while some of the solids will flow through, or some of the liquids, some of the slurry will flow through the filter, while some of the solids get stuck on to the bed particles And that's how the depth bed filter works. Magnetic filters simply use the principles of magnetism to separate particles. So the magnetic field permanently magnetizes solid particles in the slurry. These strongly magnetized ferromagnetic particles align along the magnets and accumulate to form a filter medium. Ceramic filters can be used on process streams up to 900 degrees Celsius and at high pressure. They are very resistant to corrosion and have a high collection efficiency relative to bag filters. Ceramic filters are most often used to clean up high temperature off gas streams to meet air quality regulations. They can also be used as an alternative to bag filters to meet particulate emissions targets. A Nutshaped filter is very useful because it can perform reactions washing and drying all in the single unit, and they are often used for hazardous materials or in industries that require a very sterile environment. So a Nutshaped filter often uses pressure to drive the filter cake through the medium. And that is my slideshow for y'all. So y'all please drop a like, comment in the down low if you have any questions, and I will try to answer to my abilities. Please subscribe, and I will drop a video next week.